Hello everyone and welcome to Unit 8. Today I'm going to be talking about learning target number 1, which gets into chemical reactions a little bit. And today's topic, basically we're talking about chemical versus physical changes with learning target 1 itself. So students need to be able to do the following. They can correctly identify chemical and physical changes. They can explain chemical versus physical changes using the proper scientific terminology. And we're going to discuss definitions here for those in a little bit. And then they're going to use evidence in a unique scenario to identify chemical and physical changes. So what this means is you're going to be given a multitude of different types of scenarios, and you have to identify whether it's a chemical, physical change, or both, depending on the scenario. So just kind of give you a sense of what we're talking about. You can kind of look at this picture. We have physical versus chemical change. A physical change would be, something like water into ice. That is an example of a phase change. That's a physical change. A chemical change would be where the actual substance kind of changes chemically. So hydrogen peroxide into water, that would be an example of a chemical change. So what are the exact definitions, types of changes in matter? A physical change is any change to a state of matter that does not change the arrangement of atoms in a compound. So, for example, if I ripped a piece of paper, it's still paper in terms of its chemical makeup. However, I changed the form of it. That is an example of a physical change. So any phase change or change of the physical form without changing the chemical makeup of the substance or material, that's going to be a physical change. On the opposite end of that is the chemical change, and chemical changes involve any change to a material or state of matter that does change the arrangement of a compound. So if I were to, for example, the hydrogen peroxide, hydrogen peroxide's chemical formula is H2O2. If I were to change that into water, the chemical formula of water is H2O. So there's a difference there in the chemical makeup. And that would be a chemical change. When we look at physical changes, again, no rearrangement of the atoms in a compound. The chemical bonds are not broken. So this is kind of a key characteristic, that the chemical bonds are not going to be broken in this case. Molecules remain the same throughout this process. So, for example, water into ice. Ice is still, chemically speaking, water. So it's just in a different phase change, right? Basically, any phase change is a physical change. Crushing a soda can, cutting a piece of paper in half, those are all different examples of physical changes. And again, the chemical makeup of the substance is not going to change. In a chemical change, the arrangement of atoms in the compound is changed, and the chemical bonds are broken and reformed. So example, iron rusting, all right? So if you have a car that's rusty, that's basically a chemical change that is occurring. Cooking, any type you cook, like an egg or like a steak, you're what's called denaturing a protein. That would be an example of a chemical change. And burning of gasoline, obviously you turn gasoline, you can light it on fire, it'll change into a flame. That would be a chemical change occurring. Anywhere where there's smoke, there's going to be maybe light emitted, color change. A lot of that is going to be evidence of a chemical change. So again, more evidence of chemical changes. Gas is produced, temperature change, a precipitate form. So this is when we have two liquids come together and a solid forms out of that. That's called a precipitate. Like I said before, a color change will occur, or maybe a new odor is produced. So that would be an example of a chemical change as well. So here, to kind of finish up, we have some examples here. Just going to kind of go back through this. Here we have ice melting. All right, is this chemical or physical change? And we'll review this in class as well as a kind of a warm-up to identify. Here we have a rusty nail. Fireworks. Basically putting sugar into water there, so this would be like Kool-Aid. Burning of a candles. And leaves changing color. So basically, to review then, basically you need to know three things. Number one, correctly identify chemical versus physical changes. So you have to be able to identify them in a given situation. Explain the difference between them using proper scientific terminology. So I gave you the definitions and how to tell the difference between a chemical and physical change. And then you're going to use that how-to evidence to apply that to a unique scenario. So what we did with the pictures at the end of this presentation. So that's basically the learning target. We'll be doing a couple of labs to simulate this better in class, and we'll kind of go from there. So let me know if you have any questions. Thank you.